Hello dear students, in this video lecture series already we completed 269 question. In last class we started sampling and sampling theorem. Now only two chapters are left, sampling and sampling theorem and DFT, discrete Fourier transform. So this was the question number 269. Okay, and here next is question number 270. See, remember this thing. This is sampler. Which is doing sampling process. And sampling process is nothing but converting continuous time signal into the discrete time signal. This is sampler. Here this signal is x of t. Here t become NTS, and here this is the x s of t. Correct? Okay. S stands for sampled signal. Okay, sampled signal after performing sampling. And suppose if Fourier transform of this one is x of omega, then here sampling frequency fs, which is nothing but 1 upon ts, it can be omega s also, guys. You can write omega s also. Then here it's a Fourier transform is given by, it's a Fourier transform x s of omega, which is equal to 1 upon ts summation x of omega minus n omega s, omega minus n omega s, where n is from minus infinite to plus infinite. Correct? Here this signal is having maximum frequency fm. Correct? Maximum frequency fm, or highest frequency of x of t, maximum frequency of x of t. Then what is the Nyquist sampling rate here? Here sampling frequency should be, according to the sampling theorem, twice fm in hertz, and you can write in radian per second also. You can write this in radian per second also. Okay, so omega s greater than or equal to twice omega m, and the minimum sampling rate is nothing but the Nyquist sampling rate. So Nyquist rate is nothing but minimum sampling rate, which is nothing but twice fm you can write, or you can write twice omega m. So this is the minimum sampling rate in order to reconstruct original signal without any distortion. Okay, so this concept you can remember, guys. If you put n equal to 0, then you will get x of omega. If you put n equal to 1, then omega minus omega s. So x of omega will shift right side by omega s, left side by omega s. Then again it will shift right side by 2 omega s, left side by 2 omega s. So periodic, this signal will be periodic, guys. Okay, xs of omega will be periodic. Fine. So this concept you can remember in sampling and sampling theorem, guys. Okay, and later we will see reconstruction also. Okay, question based on the reconstruction. Okay, now let us see this question number 270. Now let us see this question number 270. If the signal with amplitude spectrum, it should be magnitude spectrum, correct, shown in figure is ideally sampled at intervals of 2 pi upon 3 seconds. So sampling period is given. Sampling period is, they are saying, 2 pi by 3 second. Sampled at interval, that means time duration between two samples. It is nothing but what? Time duration between two samples, which is known as sampling period also. Ts equal to 2 pi by 3 second. So here fs will be 3 by 2 pi, inverse of this one, hertz, or samples per second. Unit will be what? Here second unit, and here unit is what? Sample per second. Okay, number of samples into the one second. So omega s we are writing because here omega is present. So 2 pi f. So it will be 3 radian per second. Unit will be what? 3 radian per second. Here you can write 3 radian per second. So this is the sampling frequency. Okay, then the frequency spectrum excess g omega of sampled signal. As I told you guys, input is x of t. Input is x of t, and this is what? Sampled signal. Sampled signal, and its a Fourier transform is xs of omega will be. So I told you guys, xs of omega 1 upon ts. 1 upon ts, which is nothing but here 1 by ts, which is nothing but 3 upon 2 pi summation n is equal to minus infinite 2 plus infinite x s omega minus, here omega is equal to 3, n into 3 guys. Okay, so first here xs of omega xs of omega, which is nothing but 3 upon 2 pi into the bracket, you can put n equal to 1. So x of omega plus n equal to minus 1. Okay, 3 plus x of omega plus x of omega minus 3, and so on guys, periodic. Okay, so first is x of omega, then you have to add x of omega minus 3. So first of all you have to shift x of omega right side by 3 unit, and then you have to add. So if you shift right side by 3 unit, simply you have to add 3 guys. So here it become, this is 1, this is 2, here this is 3, then this will be at 4, and this point will be at 5 guys. Okay, between 1 and 5. Similarly x of omega plus 3, omega plus 3 means you have to shift x of omega left side by 3 units. So it will be what? Same, minus 1, minus 2, minus 3, minus 4, and minus 5. So tell me which option should be correct answer here? Which option should be right answer? Okay, xs of omega. So it is from 1 to 5 guys. Now see, this is very much important. This is very much important guys. Okay, see, very much important. All of you please concentrate here. This is very much important concept. Omega. Okay, so here first x of omega. X of omega is nothing but this trapezoidal between minus 2 and 2 guys. Trapezoidal function between minus 2 and 2. Correct, trapezoidal function between minus 2 and 2 with amplitude is 1. Correct, amplitude is 1 guys. Here amplitude is 1. Okay, next x of omega minus 3. So shift this x of omega right side by 3 units. So if you shift it right side by 3 units, then it will be trapezoidal function between if you shift right side by 3 units, then it starts from 1 guys. It starts from 1. Okay, so it will be like this between 1 and 5. So 1, 2, 3, 4 and 5. Similarly shift left side by 2 units. So it is from minus 1. from -1 to -5. Correct. This is -5, -4, -3, -2, -1. Correct. So it will be like this. Okay. So here this is x of omega, this is x of omega minus 3, this is x of omega plus 3, guys, and you have to add all this thing. You have to add this all three, this thing. Okay, and the resultant signal will be xs of omega, resultant signal. Okay, yes. Okay, so now let us add, guys, let us add this thing. So between -1 and 1, let us observe between -1 and 1. So here this is 1, this is 0, 0, -1, -2, 0, 1, 2. Okay, let us observe between, let us add between -1 and 1. So this is 1, this is 0, and this is 0, guys. So here it will be 0. Yes or no? Here I am writing it will be here total 1, guys. 1 plus 0 plus 1 plus 0 plus 0, it will be 1. Okay, between -2 and -1, guys, see, between -2 and -1. So this is slope, this slope is 1. Correct, you can see, guys, this slope is 1 and this slope is -1. So overall slope will be 0. That is constant 1, guys. Can we select this constant 1? Constant 1 will you get? Yes or no? Constant 1, guys. This slope is +1. Here this slope is -1. Here this is 0. Correct? So +1 and -1. Total slope will be 0. So amplitude will not be 0, but amplitude will be constant 1, guys. How? See here. All of you, please concentrate here. You can see here amplitude is 0, here amplitude is 0, and here amplitude is 1. So here amplitude will be 1. Similarly, here at the center you can say amplitude is 1/2, because here amplitude is 1, here amplitude is 0, here amplitude is here amplitude 1/2. You can check, guys. Here amplitude 1/2, here amplitude 0, here amplitude 1/2, here amplitude 0, here amplitude 1/2. So 1/2 plus 0 plus 1/2, again it is 1, guys, 1 constant. Can we say like this? 1 constant. Now at this point amplitude is 1, at this point amplitude is 0, and at this point amplitude is 0. So 1 plus 0 plus 0, so it will be 1, guys. Yes or no? So what I am saying, it is constant 1 between -2 and -1, because this is +1 slope, this is -1 slope, so overall slope will be 0. That means amplitude will be constant 1. Okay, so remember this thing. So here I am writing, here already amplitude is 1 between -1 and 1. Now again we got amplitude 1 between -2 and -1 also, guys. Correct? -2 and -1 also. Similarly, right side also, guys. Similarly, right side also. Here slope is -1. Here slope is -1. And here slope is +1. So again overall slope will be 0, but amplitude constant, you can say. You can see, guys, here this is 1 plus 0, which is equal to 1. Here 1/2 plus 1/2 plus 0, which is equal to 1. Here 0 plus 1 plus 0, which is equal to 1. So amplitude remains constant, guys. Amplitude remains constant. I hope all the students are getting. So it will be again constant. Again constant, guys. Correct? Again amplitude will be constant between 1 and 2 also, guys. Between 1 and 2 also. Correct? So you can see it is constant from -2 and 2, guys. Constant from -2 and 2. Now between 1 and 5. Now let us check between 1 and 5, guys. Between 1 and 5. Sorry, between 2 and 5. From 2 to 4, sorry. Between 224. Between 2 to 4 again, you can see between 2 to 4 and between -2 to -4. So you can see guys, here you can see this is 4. Okay, now you can see guys, here this is 0 plus 1 and this is 0 guys. So again 1 you will get, correct. Here also this is 0 between -2 -4. Here also 0 and this is 1. So addition will be 1. So again you are getting 1 guys. Again you are getting 1 from 2 to 4 and here 1 from -2 to -4. So you are getting constant guys for all omega. You are getting constant for all omega. Again you will get constant. Why? Because one more signal will be there. Which one? Here n equal to 2. So omega minus 6. Omega minus 6. So if you add 6, so it will be between 4 to 8 guys. Between 4 to 8, one more signal will come. Here like this trapezoidal. One more trapezoidal will come between 4 to 6. So again here constant you will get. So it will be constant for all omega guys. It will be constant for all omega. Are you getting? It will be constant for all omega. This is Fourier transform of the sampled signal. Okay, so it will be constant for all the omega. Okay, and the magnitude should be 3 by pi guys. This magnitude should be 3 by pi, but here there is a typing mistake. Here this magnitude should be 3 by pi. 1 upon ts should be there. 1 by ts should be there. Okay, here 1, so 1 by ts. So here it should be 1 by ts, but no issue. It is 1 guys, 1 for all omega. So the correct answer is option D. I hope all the students got this. Correct answer is option D guys. Are you getting? Here it will be 1 for all omega. Okay, it will be 1 for all omega, and this is nothing but what guys? Undersampling. Now from this you cannot reconstruct original signal because this is the undersampling guys. Undersampling. Okay, you cannot reconstruct. See here maximum frequency of this signal is nothing but omega m is equal to 2. So minimum sampling frequency should be, according to the Nyquist sampling rate, minimum twice omega m. So minimum it should be 4 radian per second. Okay, minimum it should be 4 radian per second, but here you are choosing 3 radian per second. In the given question it is 3 radian per second. That's why you are getting this type of output, and from this output of the sampler you cannot reconstruct original signal. Okay, because this is undersampling. It should be sampling period should be minimum twice omega m guys. Sampling frequency should be minimum twice omega m, Nyquist rate. Okay, so remember this thing. So here right answer is option D. Option D should be correct answer, but just a change in here magnitude, it should be 1 upon ts, 3 upon 2 pi, 3 by 2 pi, because this is 1. So here it should be 3 by 2 pi. I hope all the students are getting fine. So this is question number 270. Very much interesting question. This concept you can remember. Now similarly question number 271. Similarly question number 271 guys. Question number 271. Okay. For a signal x of t, the Nyquist rate is 100. Okay, x of t signal is there. X of t signal. For this signal, Nyquist rate is 100. Okay, match list 1 with list 2 and choose the correct answer using the code given below. Okay, differentiation. Okay, differentiation doesn't alter frequency of the given signal or time period of the given signal. Okay, so that's why there is a no change in Nyquist rate. Nyquist rate completely depends on the frequency. Nyquist rate is nothing but twice fm or twice omega m. So differentiation operation doesn't alter any time or frequency of the given signal. That's why there is no change in the Nyquist rate. So Nyquist rate remains same. So Nyquist rate is 100. Okay, same. Now x squaring operation. So if we do the squaring operation like cos square theta which is equal to 1 plus cos 2 theta divided by 2. Now you can see frequency become double. Guys. So if frequency double, then Nyquist rate also double, because Nyquist rate is directly proportional to frequency. So squaring operation double the Nyquist rate. Okay, double the Nyquist rate. So here the Nyquist rate will be double, that is 200, double of that of x of t, guys. Now x of t into cos 300 pi t. This is interesting part. X of t into cos 300 pi t. Okay, if this is a multiplication, guys. Okay, this is a multiplication with cos 300 pi. Okay, here now see, if the Nyquist rate is 100, then what is the maximum frequency? It will be 50, guys. Maximum frequency will be 50. Okay, now see, multiplication result in, see, suppose cos one signal is cos omega 1t, and multiplication another signal, it can be sin or cos omega 2t. So multiplication result in two frequencies. One is omega 1 plus omega 2, and one more is omega 1 minus omega 2. Difference you have to take. Okay, so here in the given question, x of t multiply with cos 300 pi t, guys. Correct? X of t into cos 300 pi t. Already each and every concept I taught in the comprehensive manner in this course, guys. In this course. Okay, now this is the extra questions I am providing. So here frequency FM is 50 hertz, just we calculated from this Nyquist rate, and here 300 pi, that means here frequency F1, let us mark this is 150. So multiplication results in two frequencies, FM plus this one, that is 200 hertz, and FM minus this one, you have to take only magnitude, that is 100 hertz. So there are now two frequency after multiplication. So for the Nyquist rate, you have to take maximum frequency. So 2 into maximum of these two frequency, that is 200 and 100. So it will be 400 hertz, guys. It should be 400 hertz. Correct? 400 hertz, guys. Okay. So it should be 400 hertz. So for this Nyquist number 4, correct match is number 4. For first one same, number 2. For second it is number 3, guys. And x of 2t, here x of 2t, again t become 2t, so frequency also double, guys. Frequency also double. Okay, x of 2t. Now only one x of 2t, guys. Time scaling. So time scaling correspond to what? Here time compression become frequency expansion. Okay, so here finally it is 1, guys, number 1. So 2341 option A should be correct answer, guys. Option A should be right answer. Option A should be correct answer, guys. Okay, fine. Okay, great. So option A should be 2341, guys. 2341. Yes, option A should be correct answer of this question. Option A is the right answer of this question. So this is question number 271. Okay, here next question number 272. X of t equal to 1 by t sin 3 pi t and cos 2 pi t is sampled with sampling interval ts second. What is the value of ts such that no aliasing will take place? Means minimum sampling rate, sampling frequency fs should be greater than twice fm. Okay, so here 1 upon ts should be greater than 2 into 1 upon tm, guys. Okay, so x of t signal is given, here sin 3 pi t and here cos 2 pi t. So here fm1 for this, it is nothing but 3 by 2, and here fm2 which is nothing but, here it is 1. Correct? 2 by 2, that is 1, guys. So sampling frequency should be greater than or equal to twice fm. So 2 into 3 by 2, guys. 3 by 2, that is fs should be greater than or equal to 3. So 1 upon Ts should be greater than or equal to 3. This implies Ts should be less than or equal to 1 by 3 second. 1 by 3 second. It's a easy question, guys. Correct? Yes or no? Are you getting? So which option should be correct answer? Which option should be correct answer, guys? Here the right answer is 1 by 3 second. So option C, guys. Option C should be correct answer of this question. Correct? Option C is the right answer of this question. Fine? So these are the important questions from the sampling and sampling theorem, guys. This concept you can remember. Okay, this concept, guys. This is the sampler. In that we have to replace T with NTS. X of T is the signal, continuous time signal. Here we are Fourier transform of is X of T is X of omega, and it has a maximum frequency FM. Okay. Now here, in order to reconstruct original signal without any distortion, the minimum sampling period, sampling frequency should be greater than or equal to twice FM according to the sampling theorem, or we can write omega as greater than or equal to twice omega m. And minimum sampling rate is known as the Nyquist rate, which is nothing but twice FM or twice omega m. Now output is sampled signal XS. S stands for the sampled signal XS of T, whose Fourier transform is this one, 1 by Ts summation n equal to minus infinity to plus infinity x of omega minus n omega s. Okay, so this concept you can remember. Now next question number 273, guys. Question number 273. Question number 273. If 100 Hz is a sinusoidal signal sampled at 140 Hz, 90 Hz and 30 Hz, then the aliased frequencies correspond to the each, I think. I think something is missing in this question. Later we will see. Question number 273. Okay, now see, this is very much important, guys. Question number 274. This is the question number 274. 273. Later we will see. 274. The block diagram of a sampling and reconstruction of a signal x of t equal to 2 plus cos 50 pi t is shown in the figure below. Sampling period is 0.01 second. Here ideal reconstruction. The frequency spectrum of the sample signal is dash, that is here. Sample signal here, x s of omega. Okay, x s of omega. Okay, this is the first question, and I think same, but this is second question. So this is the complete sampling and it's a reconstruction to get back original signal, guys. To get back original signal. Okay. Now see here, input is what? 2 cos 50 pi t, guys. 2 cos 50 pi t. Here I am writing input signal. X of t is nothing but 2 plus cos 50 pi t. So this is DC, guys. This is DC. Okay, whose Fourier transform will be what? 1. 2 pi del omega, and here pi del omega minus here Fourier transform. See, Fourier transform of constant 1 is nothing but 2 pi del omega. And what about cos omega ct? Cos omega ct, whose Fourier transform is given by pi into the bracket del omega minus omega c, impulse at omega c, plus one more impulse present at omega c, guys. Remember this thing. Correct? So if you take Fourier transform of this one, input signal, Fourier transform of this one, that is x of omega, first Fourier transform of input, then it will be 2 pi, 4 pi here. It will be 4 pi, guys. 2 is there. So that's why 4 pi del omega. Impulse at origin, here pi. One more impulse at omega c equal to 50 pi. So omega minus 50 pi. One more impulse present at minus 50 pi. Correct? Omega minus 50 pi, guys. So graphically, if we represent this, it graphically, then it will be like this. omega, here x of omega, Fourier transform of the input signal. So one impulse at origin with weight 4 pi, correct? One more impulse at 50 pi, one more impulse at minus 50 pi. So 0, here weight is 4 pi, here weight is pi, here also weight pi, guys. This is at 50 pi omega and this is at minus 50 pi. So this is the Fourier transform of the input signal. Okay. Now here next read the question. Sampling period is given 0.01 second. So Fs will be 1 upon Ts, which is nothing but 100 samples per second, 100 hertz, or you can write 100 samples per second, and the sampling frequency in radian per second, that is 2 pi f, that is 2 pi into 100, which is nothing but 200 pi, guys, 200 pi, okay, which is nothing but 200 pi. So the output omega s, that is here output of this sampler is nothing but x of n, xs of t also. You can write this is nothing but xs of t also, and t become nts. So you can write discrete time signal. Of course it will be discrete in time. So whose Fourier transform is xs of omega, which is given by, I told you, 1 by ts, 1 upon ts, summation n is from minus infinite to plus infinite, x of omega minus n omega s, correct, n omega s. So here it will be, you have to shift right side by 200 pi and left side by 200 pi. So x of omega minus n times 200 pi, guys. So you have to shift x of omega right side by 200 pi, multiple integer of 200 pi, and left side by multiple integer of 200 pi. Okay. So here it will be c, x of omega, then x of omega minus 200 pi, x of omega minus 400 pi, x of omega minus 600 pi. Similarly left side also, guys. So how it looks, guys? It looks like this. First draw x of omega. So here x s of omega, output of this sampler in frequency domain. So first later I will mark magnitude I will mark later. So this is 0 origin, DC 50 pi, this is minus 50 pi, correct. Okay, this is x of omega. Now n equal to 1, if you put n equal to 1, then you have to shift right side by 200 pi, n equal to 1, right side by 200 pi, that means simply you have to add 200 in each and every point. So if you add 200, then it will be at 150, this impulse will be at 200, and this sample will be at 250. So here correct, and as this is a even function, so same thing you can write for the left side also, for n equal to minus 1. So this will be at 150 pi, this is at 200 pi, and this will be at 250 pi. Same thing for the left side also, minus 150 pi, minus 200 pi, and here also minus. So minus 200 pi, minus 150 pi, and minus 250 pi, correct, and so on, guys, and so on, periodic. It will be periodic, guys, and so on. Okay, again you can add here. See, if you put n equal to 2, then you have to add 400 pi. So it will be at 350 pi, 450 pi, and 400 pi and 450 pi. Similarly negative side also, Magnitude later you can check. Okay, magnitude later you can check. So here, out of this, which option should be correct answer? See here, which option? Option A is not possible because center is missing. This DC is missing, guys. Here, this DC is missing. Okay, in option A you can see center at DC is missing, guys. Okay, so option A is not possible. Now option B, guys. Okay, at DC here, yes, present impulse, one impulse, second 50, minus 50, then 100 pi. No, guys, 100 pi is not possible. Okay, so option B also not possible. Option B not possible. Next you can see, yes, at the center, center is this present? No, guys, center impulse is not present. See, impulse is missing. Center DC impulse for this DC is missing, guys, in option C. So option C is not possible. Now you can check option D, guys. Okay, and option D, yes, this impulse is present. Then at 50 pi, 150 pi, minus 150 pi, minus 50 pi. Okay, then here next impulse is at 150 pi, 200 pi, 250 pi. Similarly here minus 50 pi, so minus 200 pi, minus 150 pi, minus 200 pi, minus 250 pi. Yes, this is possible. Option D, guys, same as our. Now we are talking about the amplitude, guys. Okay, amplitude of this one. So amplitude you can see, guys, simply you have to divide it by 1 by Ts. You can see here x of omega divided by 1 upon Ts. So here 4 pi is there. Here I am writing, see, this is 4 pi. So 4 pi divided by 1 upon Ts, which is nothing but 4 pi 1 upon Ts. 1 upon Ts. So Ts is equal to 0.01, which is nothing but 100. Okay, 0.01. So it will be 400 pi. So this will be 400 pi, as I told you. Similarly, again you have to multiply with 100. So this will be at 100 pi. So this is 100 pi, and this is also 100 pi. Again this is 400 pi. So 400 pi, 100 pi, 100 pi. Okay, simply you have to multiply with Fs or divided by Ts. So you can check in option D. See here, 400 by pi, and this is 200 pi. Let me check once. Here it should be pi, guys. It should be pi. So I think there is mistake. It should be 100 pi, guys. This is right only. This is correct only. If you are writing 2 pi here, if you are writing 2 pi, okay, then divided by 2 will come into picture. So here magnitude should be pi only. Here this magnitude should be pi only, guys, and it should be 100 pi. It should be 100 pi only. Okay, either typing mistake in this one, 2 plus 2 times cos 50t, or if it is cos 50t, then here it should be 100 pi, because Fourier transform of cos omega ct is nothing but pi omega minus c plus omega plus c. Okay, 2 get cancel out, that's why 2 get cancel out, that's why. So here pi multiply by 100, so it should be 100 pi. Here also 100 pi, guys. So there is a typing mistake. It should be 100 pi, guys. It should be 100 upon pi. Wait, 100 by pi. Okay, just wait for a minute. 1 upon Ts should be there. 1 upon Ts, then 400 pi, then 200 by pi. Okay, so 1 upon Ts. So Ts is 0.01 second. Ts is 0.01 second. They are arguing. Okay, so I think there is mistake here in magnitude. It should be 400 pi and it should be 100 pi, guys. I think there is a mistake, because this is right only. This is correct only. 1 upon Ts summation and is equal to minus infinite to plus infinite. Okay, fine. So here the right answer is option D, guys. The correct answer is option D. Option D should be right answer of this question. Okay, yes, option D should be correct answer of this question, guys. Let me check once. Okay, let me confirm once, guys. So here output should be yes, see, yes, see here 1 upon Ts only, guys. See, 1 upon ts only, correct? See, you can see 1 upon ts summation n equal to minus infinite to plus infinite x of omega minus n omega s, as I told you guys. Okay, so this is right only. Okay, we confirm just 1 upon ts summation n equal to minus infinite to plus infinite x of omega minus omega s. So our answer is correct, guys. Our answer is correct. So maybe typing mistake in the question, maybe. Okay, maybe typing mistake in the question. Fine. So this is what question number 274. Here it should be 400 pi and this should be 100. Okay, so next here what I'm saying guys, here this is nothing but NFS plus or minus FM guys. Here input frequency, observe this one, see input frequency is FM, input frequency that is sorry x of t has a maximum frequency FM, here sampling period TS, sampling interval TS, and sampling frequency FS. Then output is sampled signal whose frequency just we have seen guys, NFS plus or minus FM. Okay, and this is the ideal low pass filter. This is very much important guys, ideal low pass filter. So whose frequency response like this guys, whose frequency response will be like this. This is omega, this is omega. Here you can write omega m also guys, omega m, this is omega s. Okay, you can write this is omega s, and this is n omega s plus or minus omega m guys, plus or minus omega m. Okay, and the frequency response for this filter. Okay, so 0, sorry, here cutoff frequency 0, omega c and minus omega c. Okay, here magnitude is 1. So this is the magnitude response of the low pass filter. Low pass filter. So I think there was a sound problem in question number 274. Question number 274. Okay, so don't worry, next part we will continue guys. I think there is a sound problem. Okay, so I think there was a sound problem in question number 274. So in next part I will start from this question guys. I think there was a sound problem in question number, from question number 274, sound was gone guys, correct? So I will start from this question from in next part guys. Okay, question number 274 guys, fine. Okay, so thank you guys, thank you so much.